welcome back to my system design series. Today we are going to cover these topics. Whether you are a student, a developer, or are simply curious about how modern databases work behind the scenes, you are in the right place. Today we are going to break down these 4 replication methods. We have already discussed leader-based replication in lecture number 20 and 21. If you haven't watched that, then kindly watch that video, understand it, and then jump on this session. First is statement-based replication. Think of this as writing down the exact copy of instruction and then passing that note along. Suppose our head chef gets an order to prepare medium latte. In database, it will record as like this query. Insert into the orders is a table name, and then we will pass the order ID, drink that is a latte, and the size that is a medium. And the values is this. The leader logs the statement and sends it to all the follower nodes, which execute it exactly as written like this. However, there are challenges. For example, what if the instruction uses the now function to record the current time? Each follower might calculate different timestamp. Or if you have the auto incrementing the field, the results can differ from one follower to the next. This method is simple and compact, but is sensitive to non-deterministic functions and dependencies. Despite these challenges, this statement-based replication is still used in the older versions of SQL and some specialized databases like WAL-DB, where every transaction is carefully controlled to be deterministic. Next, let's discuss write-ahead log or WAL shipping. This method goes a step further into the details. Imagine our head chef not only write down the order but also record every tiny detail about the preparation, the exact weight of the ingredient, every precise step, and even the time taken for each action. This detailed record is then sent out to all assistant cooks. In databases, the WAL is append only log that captures every single byte change. When the write happens, it is recorded in WAL and then the log is transmitted to the followers. The followers replay these changes to rebuild an exact copy of the leader's state. And this is how it will look like. This is offset 2048. This is the exact location inside the file. Update block 17. So, block number is 17. Change bytes 45 to 52 to latte. So, whatever the bytes inside this 45 to 52, it will be changed to latte. Okay. Then there is a WAL, write ahead log. Inside this particular number or section of the file, insert into the block 18. We are inserting into the block number 18. Add a new order record for order 101. Here the order ID is 101 and then we will insert the order. Okay. This method ensures every precise replication of the changes. But because it operates at such a low level, it is tightly coupled with the storage engine. If the storage format changes between the versions, then the follower may not be able to understand this log. Write-ahead log is used by robust systems like PostgreSQL and Oracle, where precision and crash recovery are very important. Third is logical replication, that is a row-based replication. Instead of capturing every byte level change, logical replication captures high level, that is a row specific events. This means that rather than logging every minute detail, it records the big picture of what changed. Imagine that our head chef sending the summary to a branch. A new order was placed for medium latte. Assistant chef or assistant cook doesn't need the recipe instructions for that. They just update their order board on the basis of the summary. So the logical log entry will look like, here's a table name, that is the orders, the action is insert, and the data is like order ID is 101, drink is latte, size is medium, and here is the timestamp. Logical replication is highly flexible because it abstracts the low level details. The leader and the follower node runs on the different versions of the database software or use different storage engines. This decoupling makes upgrade or cross-system integration like feeding data to data warehouse much easier. Systems like MySQL set to logical replication mode and many modern NoSQL systems use logical replication to balance flexibility and consistency. Finally, let's cover trigger-based replication. Unlike built-in replication methods, triggers are special procedures which are fired automatically when certain events occur in the database. Think about it like pressing a bell in the kitchen which rings every time the order is placed. When the bell is rang, the designated employee will immediately simplify the order and write down it into the log. This log can be processed and sent to the other systems, whether it is a backup database or a reporting system or even a different type of database. So here you can see create trigger. This is the name of the trigger, is a replicate order. After insert on orders, this means that this trigger will run after a new row has been added to the orders table. For each row, it means that it will run once for every row that are inserted. So if 5 rows are inserted in one query, this trigger will run 5 times. So between the begin and end, this is the logic which trigger will execute. This lines inserts a copy of the new order into the replication log table. Okay, so order ID and everything is mentioned. While trigger-based replication provides a lot of flexibility, allowing you to filter data, transform it, or replicate to heterogeneous systems, it also comes with higher overhead. More custom code means more chance of bug and potential performance impacts if not managed carefully. Some tools like Oracle Golden Gate and Bucardo for Postgres utilize trigger-based approaches to meet specific replication needs that go beyond the standard methods. Now that we have seen the technical details, let's connect this concept with the real-world systems. Earlier version of the SQL were primarily using the statement-based replication. But as the system grew, more complex and non-deterministic operations become more common. MySQL shifted to row-based replication to avoid issues with unpredictable function calls. This change helped MySQL to provide more robust data consistency. Both PostgreSQL and Oracle use WAL replication. This method ensures that every minor detail is captured, making it excellent for crash recovery and ensuring data integrity across all nodes. With the rise of cloud-based database like AWS or Google Cloud Spanner, replication has taken on new dimensions. These systems often combine techniques, for example, using logical replication to integrate with analytics platform or trigger-based replication to sync up with the microservices in real time. Consider how Amazon or Netflix handle massive data flows. These systems rely on these replication methods to ensure that updates in one of the data centers are reliably and quickly passed on to other data centers of the world. This ensures that no matter from where you access their service, you get the same data almost instantly. This real-world example shows that each replication method has its own strength. The best approach often depends on the specific needs of your application, whether it is consistency, flexibility, or performance. Let's wrap up. We have talked about 4 different techniques of logging and replication methods. I hope I have simplified the concept, and if you like this video, don't forget to subscribe to my channel, give a like and comment down below if you have any doubts. See you in the next video.